Hi everyone, Mr. Skelton here. We are starting Unit 4 today with lesson number 1 in congruent figures. Unit 4 is really about triangles, and you're going to see some today, but we're going to be talking about congruent triangles, and this is our proof unit. Okay, this is where you're going to be making a lot of proofs over the next coming weeks. And so today what we're going to do is kind of introduce you to what we're going to be proving, and that is congruent figures. And so I printed your notes off in color so you could see some of the corresponding aspects of congruent polygons. So we're going to talk about polygons first, but then we're going to move more specifically to triangles as the days move forward, as the lessons go. So right here, this is the most important part. Really, it kind of sets the tone for the whole unit. Congruent polygons have congruent corresponding, that's a big word there, corresponding, okay? Parts, sides, and angles, okay? That means if two things are congruent, if two polygons are congruent, if two triangles are congruent, then everything about them in the same location is equal, all right? And so it says when you name the parts, you must list them in the same order. I could probably highlight this whole thing, but the same order is important, and that's why it's color coordinated. For example, this symbol right here is important. This means congruent, okay? So this is A, B, C, D is congruent to E, F, and G. These two polygons are congruent. And so like A is the left-hand side, but if you were to like fold this over, right, if you were to match this figure with this figure, A would go with E, B would go with F, D would go with H, and C would go with G. And I color coordinated them for you as well. Red, red, green, green, blue, blue, black, and black. You'll also notice that they're color coordinated in how you list them. Red is first, so A goes with E, blue, blue, purple, purple, or black, whatever it is, and then D and H, which is green and green. You notice over here, if we're talking specifically about the angles, A is with E, C is with G, B is with F, D is with H. Sides, if I say AB and I list AB, then I need to say EF as its congruent part. It has to go in the same order. That is so important, okay? If I said, I know this one says BC, but let's just say I flipped it around and I went CB. If I went CB, I'd have to name this one GF. You have to stay in the same order. So you can see red, red, blue, 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 purple, 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 green, 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 red, red. The order in which you list things is very important, okay? So let's try some of this and put it into practice a little bit with a couple examples. Number one says, name the congruent corresponding parts of the figures below. So based on the markings here, this is good review, these are congruent to each other. So for example, we're talking sides. So if I said CB, what is congruent to CB on this picture right here? I went from C and went to B. I look at clues, like see how this has one little tick mark there and this has two where B is at? So I'm going to look here where it has one and it has two here. Looks like I'm missing a letter. Oh man. All right, let me put in a letter here. RP, let's make this one a Q. How's that sound? A Q. All right, we'll make that a Q there so it works. Okay. So if I said CB, C to B, I need to say R to Q. R to Q. Okay. Let's do another side. Let's say CA. Again, I'm just picking random. You don't have to call it CA. I could have called it AC. I'm just saying CA. So I'm looking for clues. One tick mark where C is at to 3. So over here, where is it 1 to 3? R to 3P. So R to P. And then I have A and B. Okay, again, I'm starting with all the sides over here first. So A, B. A has got 3 markings on it. B has 2. So I want to go from 3 to 2 over here, which is P to Q. Okay. Angles are the easier ones. So what matches up with angle C? What's congruent to angle C? That has one tick mark or one swoop. This one has swoop, so angle R. What matches up with Q, or no, I want to start with B. Angle B. What matches with B? B's got 2 swoops, Q's got 2 swoops, angle Q. Last one, what has 3 swoop marks? Angle A. And what's angle A congruent to? one that has 3 over here, which is angle P. Okay, so everything matches up. It's a little meticulous, but that's the way you have to do it. Okay? Now, this one's always tricky. This one always gets students. I'd normally have you try this on your own, but sometimes this throws people off. They look at this. It's the same directions, right, for the most part. Name the congruent corresponding parts of the figures, and there's no picture. This one has a picture. Has stuff you can look at. Over here, it just gives you a congruent statement. Let's start with the angles first, and you're actually going to do what you did up here, right? You can look at how something is written and know that the first letter goes with the first letter on the second one. The second letter of the first one goes with the second letter of the second figure, and so on and so forth. So when we go to angles, what matches up with A? Well, what's the first letter listed here? Angle D. What matches with B? E. Angle B, congruent to angle E. And then the third letter listed is C, and that matches with F. Okay? Now, sides, you're just going 2 sides. So if I said AB, so AB would match up with the first 2 letters, which would be DE. Right? I could say BC, which is the last 2 letters. BC matches with EF. So what's the only combination that I haven't used? I used AB and BC, so I need, what's the third combination? AB, BC, I need A and C. So here's A, here's C. So the first and the last letter goes with the first and the last letter, which would be DF. All right? Now, you can also draw a picture. Some students will do this. They'll go A, B, and C is congruent to, and they'll draw another picture. Now, you have to go in the same order. So if you went A, B, C, you got to go D, E, F. And then you can match up, and now you have a visual. All right? Okay, moving on. Down at the bottom, now we're just doing some algebra with it. So it says in the diagram, DEFG is congruent to LKNM, which these 2 figures are congruent. All right? And so I want to find, I'm going to find y first, which is right here. So this says 5y plus 6. Hope you can read that. I'll zoom in a little bit here for you. 5y plus 6. Okay? And move this up. That's angle L. Well, if I look at angle L, L is listed here. What matches with L on this figure? That would be D. So this 5y plus 6 is equal to whatever D is. D is 93. So now I'm just going to solve that, okay, for y. So I would minus 6 from both sides, and I'd get 5y. I'd take 93 minus 6, get 87, and divide by 5, and y equals 17.4. Okay? It says to find x. Now, x is listed as nm. So here's nm. What matches with nm over here? fg. So you have 5x plus the 2, this is a side, is equal to, fg is 12 feet, so you set it equal to 12. So you get 5x equals 10, so x would equal 2. Okay? Go ahead and hit pause and try number 1 right next to it and see if you can find the measures of the numbered angles. So you have to find angle 3 and angle 4. All right, we're back. Now the one thing that the directions is missing is telling you that these 2 figures are congruent, but I'm telling you right now that they are, okay? These 2 figures, doing a crummy job of drawing them, they are congruent. So I know that R is going to match up with W, so I know that angle 4, which is right here, has to be 135 degrees. Excuse me. Angle 3 is right here in this corner, which is S, and S matches with M. M is 90, so angle 3 has to be 90 degrees. Okay? All right, let's flip it over. See what we have on the back side here. Okay. This is called, let me zoom out a little bit here. This is called the third angle theorem, and this is honestly common sense, and I'll show you why, and then we'll kind of talk about how you're going to use it, or how you could use it. Basically, it says this: if 2 angles of one triangle are congruent to two angles of another, then the third angle are also congruent. So here you have A is equal to D and B is equal to E. So that means C, angle C, has to be congruent to angle F. Let me show you, put some numbers in here. If I called angle B 90 degrees, that means angle E would have to be 90 degrees, right? And if I said that angle A was 60, that means angle D would have to be 60. Now we just got done doing a unit on how to find, if I called that X, how to find X. Well, you know that a triangle makes 180, so 90 and 60 makes 150, so what does X have to be? That would have to be 30, right? Same thing down here, that has to be 30 for the same reason. So it's kind of a common sense theorem, but it is important, okay? Now, this takes a little bit of time. We need to talk about proving triangles congruent. So if you're going to say, this is really, 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 really important, all right? All right, put a little star next to it, whatever. This is going to kind of set the tone for what we do moving forward, okay? Get this straight here for you. If you are going to prove to me that two anythings are congruent, you need to tell me, just like on the front here, if you're going to tell me that these two things are congruent, then you need to tell me that all their sides are equal to each other and all their angles are equal to each other. Remember this part, sides and angles. This right here was all the sides, and this right here was every single angle. We didn't skip anything. We covered all four sides, here, 1, 2, 3, 4. We covered all four angles, 1, 2, 3, 4. So on the back, when we're talking about proving triangles congruent, you need to show two things. Number one, all corresponding angles are congruent. And number two, all corresponding sides are congruent, which is no different than what you did on the front. There's the corresponding sides, there's all the angles, that's what you're trying to do, okay? Now, let's think about this for a second. Triangles. If I want to show that this triangle here is congruent to this triangle here, how many angles do you need to show me in a proof that are equal to each other? 3. How many sides would you need to show me that are equal to each other? 3 sides. So when we start doing proofs, you're going to have to show me that 3 angles are equal to each other. All 3 angles here are congruent to all 3 angles here, and all 3 sides from here are congruent to all 3 sides there. All right? So let's take a look here. Let's take a look at some of these. It says, these are some basic questions. It says, decide whether the triangles are congruent. Justify your answer. All right? So if you look at these two, and again, some of these you may need to turn and flip and rotate to match up, but let's take a look. I'm just going to start making a list. Angles. Let's match up. Let's see if we can find the angles. If I take this figure and kind of take D and flip it up, angle A is congruent to angle E, right? This F is a 90-degree box, so C, so angle F is congruent to angle C. Now, how do we know that B and D are equal? We know it from the third angle theorem right here, right? If 2 angles of one triangle are congruent to 2 angles of the other, then the thirds have to be congruent. So I know that angle B is congruent to angle D. If I was making a proof, it would be the third angle theorem. That's why we can say that, okay? Now look, 1, 2, 3. All 3 angles from this triangle are congruent to all 3 triangles or angles from this triangle. Let's do sides, okay? Does AF match up with EC? It does. It has a single tick mark. So AF is congruent to EC. Remember, we're listing things in the correct order. If I say AB, what's congruent to AB? ED. And then the last side, 3 tick marks. If I say BF, what's BF congruent to? If I said B to F, I'd have to go D to C. D to C. 1, 2, 3 sides. 1, 2, 3 angles. Decide whether the triangles are congruent. Justify your answer. Yes. All 3 sides and angles congruent. Okay? Now, I'm not going to have you list all of this for each one. Let's just take a peek at these and kind of knock them out. And then we'll go from there, okay? So let's look at what we have here. We want to say if these are equal to each other, yes or no. All right? Now, let's do angles first. A and E match up. D and B match up because they have 2 swoops. I should say not angle D, but this part right here that has 2, that has 2. Okay? 3 and 3 match up. 4 and 4 match up. Single tick mark, single tick mark. And honestly, this gets a double tick mark. And the reason I can put that there is because these 2 triangles share DB. And so DB has to be congruent to itself. When we start doing proofs, we would say DB is congruent to DB. And the reason would be the reflexive property. You'll probably remember that. This is actually yes. Okay? We can say yes, these 2 triangles are congruent because all 3 angles, we can see the markings, and all 3 sides, 4 and 4, single tick mark, double tick mark. Yes. Let's look at 3. 3 shouldn't take you very long at all to say whether it's yes or no. Now, there are no markings for angles here. I can say no right away. Now, to the naked eye, does this triangle look like it's the same as that one? It does, but there's no markings. There's no angle markings. So remember, in geometry, you can't assume anything. So that would be a no there. Even though they share this, okay, you could put 3 there, but that doesn't matter because, you know, the sides don't even match up. WV doesn't even match TV. WV has a single tick mark. This one has 2. It's a no. Okay, let's try these 2 over here. Number 1, let's take a look. Single swoop, 9 degree, 9 degree. You know that these have to be congruent because of the third angle theorem, right? DF would match up with XZ, good, single tick mark, XY would match up with DE, double tick mark, and then EF would match with YZ, 1, 2, 3, 1, 2, 3. So all 3 angles, all 3 sides from both, that's a whopping yes. Okay? All right, the last one, I'm going to actually do a proof with you on this. This is what we're going to get really good at doing here over the next couple days. So I want you to prove that triangle DEF is congruent to triangle. If I said DEF, I need to say, let's see, HGF. HGF. So remember, when we make a proof, we want statements and we want reasons. Right? That's called a 2-column proof. All right. Now, we don't have any, if you remember from doing proofs, we don't have a given statement. I'm kind of just making this one up. So we're just going to list everything, all right, that's given to us with markings. So for example, I know that angle D is equal to angle H. Angle D is congruent to angle H. And the reason I know that is given to me, right? Some people will put markings down. It's in the markings, okay? Let's focus on angles here. Number 2, we're doing all the angles, all right? And I'm going to put a little A out here for angles. Because remember, what are we trying to show? I need to show that all 3 sides and all 3 angles. So I better have 6 statements here. 3 angles, 3 sides. Now this is kind of tricky. What do you know about this angle here and this angle here? You should be saying they're congruent. And the reason is vertical angles. So let's name this. Now we can't say angle F is equal to angle F because you don't know what angle F you're talking about. So I'm going to say angle DFE, remember F's in the middle, DFE is congruent to, got to use the same order. If I say DFE, I have to say H because that is an 81. I'm starting at the 81. HFG. HFG. And the reason is vertical angle theorem. Remember, reasons have to be mathematical statements. There's a second angle equal to a second angle. Now, I know angle E, which is this one here, has to be congruent to angle G. Why? What's the reason? You know that this is 81. You know this is 81. That's equal to that. So this has to be equal to this because of the third angle theorem. So third angle theorem. Okay? Now look, in my proof, I have an angle equal to an angle, angle equal to an angle, angle equal to an angle. I have proven, I have showed that all three angles from this triangle are congruent to all three angles of this triangle. Next, we got to focus on sides. Okay? I'm going to say DE. DE's got a single tick mark. So over here, what's got a single tick mark? Now, a lot of students are going to say GH. Can we say GH? We can't. We got to say HG. All right? DE, I always look for helpful hints. D, I said DE, and D has the 81 at it. So DE, look for the 81. HG. Given. Or you could say markings. Okay? And that's a side. I'm going to put an S here for a side equal to a side. Number 5, what's got 2? DF. DF is congruent to, DF would be HF. HF. And that's also markings. Or I could put given. I know I'm writing that backwards just to show you some variety there. And that's also a second side equal to the second side. And then 6, 3 markings. EF is congruent to, if I say EF, I have to say GF. And that is given to us, or markings. Right? Now look, side, side, side. All three sides of this triangle are congruent to all three sides of this triangle. All three angles of this, all three angles here. I am done. I have just proved, so my last statement is triangle DEF is congruent to triangle HGF. And the reason is definition of congruent triangles. Congratulations. That is your first triangle proof. This is what you're going to be doing for a majority of the time in this unit. Okay? I'm sure you'll have some questions. I always have a lot of students like just start putting markings down because they think they're supposed to go there and just randomly. Like, you really have to know what you're doing. You have to know the theorems. You have to know vertical angles. You have to know the third angle theorem. You can't just put markings down on your paper because you feel like it. They can only be there because of mathematical or geometric reasons that we've covered in the past, okay? You'll get better at these as you go. I'm sure you'll have some questions, and I hope to answer them down the road, okay? I'll see you later.